Hey, welcome back to Math with Patrick. Today is March 16th. We have problem number 75 from this Daily Epsilon calendar. We're going to solve it together today. So the answer is 16, that's today's date, and we need to show how x is equal to 16. So this number on the right side of this equation is somehow the number 16. So we have 9 times sine of theta plus cosine of theta all squared. The first thing that I'm thinking about is I know that there's like this double angle identity that I could use. I know that sine of 2 theta is the same as 2 times sine theta times cosine theta. So that kind of crossed my mind seeing this, though I think I have a better idea. If I expand out that squared up here, I will get, well, the first times the first, which is sine squared theta. The notation here, it is just sine theta times sine theta. And it's just that if you put the squared here, it's a little bit ambiguous of whether you mean squaring just the theta or squaring the output. So anyways, usually it's written like this. Then I get the first times the second, which will be sine times cosine of theta. But then when I do, here, I'll just write it all out. When you multiply two binomials together, you need to make sure that you're multiplying everything, all the appropriate things. So you need to distribute all of these terms together. And so I do get 2 sine theta times cosine theta, just because of the outside and the inside terms. Finally, I will do cosine times cosine, and so I'll get cosine squared theta. And there is a trig identity hiding in here. Let's say we think of a triangle, a right triangle, with a hypotenuse of 1. And here is my angle theta. Sine is just kind of defined to be the ratio between the opposite side and the hypotenuse. Oops, I wrote that wrong. Sine of the angle, so sine of theta, is defined to be this opposite side, which I'll call, let's call it y actually, because it's a vertical distance. So it'll be opposite over hypotenuse. In this case, dividing by 1 doesn't really do much. So sine of theta will be this value right here. It'll be some value between, -1 and 1, because maybe my angle goes down the other way, in which case I might have a drop. So maybe the y will be negative, maybe it'll be positive. Either way, this distance right here is just sine of theta. Cosine is just defined to be the adjacent side, this one right here, divided by the hypotenuse. And same dealio, dividing by 1 doesn't really do much. And so this distance on this part of the right triangle is going to be cosine of that angle theta. Now, if you remember the Pythagorean theorem, we can do a squared plus b squared equals c squared. So squaring this distance plus squaring this distance down here is equal to c squared. And, 1 squared is just 1. So anytime, does not matter that angle measurement. Anytime you see sine squared plus cosine squared, it's always going to be 1. So that being said, we can use that up here. There we go. I want to erase this triangle for some room. That sine squared at the start plus the cosine squared at the end, that is just the number 1, which I'll put right here. We're still going to have plus 2 times sine theta cosine theta. And the problem statement tells us that this is 7 over 18. So I can replace that part with 7 over 18. And now it's just an arithmetic problem. And let me close my parenthesis there. Okay. X is equal to 9 times 1 plus. And then I could do the 2 times the 7. I'm just going to decide to do 18 divided by the 2. You can make your denominator smaller to increase the value of your fraction. So, alternatively, you could have just multiplied the numerators, the 2 and the 7 there, and then reduced to get 7 over 9. I think I'll just distribute here. I'll distribute the 9 to the 1, and then 9 times 7. Again, I could multiply the tops, but I notice that the 9 and the divide by 9 cancel. So this is just 9 plus 7, or in other words, 16. today's date. So using that Pythagorean identity, where sine squared plus cosine squared is just 1 no matter what, we can see that the answer today is 16. Okay, all done. See you tomorrow. Thanks for coming along as always. All right.